everyone, welcome back to week 5. So we're looking at simultaneous linear equations and linear inequalities this week. So I'm going to split the lesson into 2 parts. Okay, so we're going to start with an example. So the first example is going to be example 1. And the question is to solve the following simultaneous equations. Now with simultaneous equations, you must always have 2. So it's not a simultaneous equation if you have one equation. You have to have 2 equations. So solve the following simultaneous equations. So we're going to have 2 equations here. The first one is x plus y is equal to 7, and the second one is 2x minus y is equal to 2. Okay, so for that one, when we're doing simultaneous equations, I always like to number them. So number 1 and number 2. So you can always refer back to the equations. So we're going to be using the elimination method. Now, what that means is we're going to be getting rid of either the x's or the y's. The way we're going to do this is we're going to try and cancel them out by letting them equal 0. So for example, if I had a minus 2, how would I get 0? If I added 2, I'd get 0. If I had a 5 and I wanted to get 0, I'd take away 5. That would give me 0. So it's the same concept here. So let's just look at the x's and the y's for a minute. You have to choose which one that you're going to eliminate. And a tip I always give is look at the sign. So that's a plus and that's a minus. So if there's a plus and a minus, go with that letter. So we have a plus y and we have a minus y. Well, that's going to give you 0. So say, for example, if it's 1y, take away 1y, that will give you 0. So that will actually cancel out. So we don't do that in there. So they cancel out. Now what we do next is we're going to add the x's. So x plus 2x gives us 3x is equal to 7 plus 2 gives us 9. So now we can solve for x. So if 3x is equal to 9, x is equal to 9 divided by 3. Therefore x is equal to 3. So that's one of your solutions. Now, it says to solve, so we have what x is. Now we have another letter, we have y as well. So we need to now go back and get what y is. So when we're doing this, you pick an equation, and I'm going to pick equation 1. It works for equation 2 as well. So I'm going to pick equation 1, and equation 1 is x plus y is equal to 7. Now we have just figured out that x is 3. So anywhere I see x here, I'm going to put in 3 instead. So it's going to be 3 plus y is equal to 7. I want to get letters to one side, numbers to the other. So I want to leave y here. I'm going to bring the 3 over beside the 7. So if there's no sign in front of the 3, we assume it's positive. So we assume it's plus 3, so we need to bring it over here beside the 7. So it's now going to become y is equal to 7 minus 3. So y is equal to 4. And that's it. So they're very straightforward. So we're going to do a couple of other examples. But try and remember that we're using the elimination method and we want to get rid of either the x's or the y's at the start. Okay, so we're moving on to example 2 now. And again, the question is to solve the simultaneous equations, or solve the following simultaneous equations. And this time we're given 3x is equal to 4 minus y. And the second one is 5x minus 4y is equal to 1. Okay, this is a bit of a trickier one. So you'll notice that this equation, you have 3x is equal to 4 minus y. But this equation, you have x's, you have y's as equal to a number. So what we want to do is we want to rearrange the first equation here so that we have x and y on one side of the equation. So first thing I do is number them. This is equation 1, this is equation 2. Now I want to rearrange equation 1, and the reason being is because I want equation 1 to be the same format as equation 2, where you have x's and y's on one side of the equation and then numbers on the other. So I want to bring the y over here beside the x. Okay, so I'm going to rewrite equation 1. Equation 1 is going to be 3x. Now we're bringing the minus y over beside the x. So when it's minus on this side, when it crosses an equal sign, it becomes a plus. So it's going to be 3x plus y is equal to 4. So that's now your equation 1. And your equation 2 is going to go underneath it, and that's 5x minus 4y is equal to 1. Okay, so now we're going to solve it. So remember what I was saying before, if you see a plus and a minus, which we have here, we're going to go for that because it makes your life a lot easier when you're figuring out what to do. So you have a plus and you have a minus here. Now you have a y and you have a 4y. So I'm going to just do my rough work up here. I have a y, so I have a plus y, and I have a minus 4y. How would I get 0 there? Well, if I made that a plus 4y, so 4y take away 4y gives me 0. So how would I make that a 4y? It means I multiply it by 4. Now, when we're doing that, we can't just multiply the y by 4. You need to multiply the whole line by 4. And just to reiterate, the reason I'm multiplying the whole line by 4 is because I want this to be a 4y, and the only way I can do that is multiply it by 4 to get rid of the y's. So I multiply this whole line by 4. So I usually put it in brackets like this. So we're multiplying the whole line 1 by 4. Okay, so I'm going to rewrite equation 1. So 3x by 4 gives me 12x. Y by 4 is 4y. Is equal to 4 by 4, which is 16. Equation 2 we didn't do anything to, so we're going to put 5x minus 4y equals 1. Now you'll see what has happened here. You have a plus 4y and you have a minus 4y, which means we can get rid of them. So cross that out. 12x plus 5x is 17x. Is equal to 16 plus 1 is 17. So now we can solve for x. So x is equal to 17 over 17. So x is 1. So we now have a value for x. We need to go back and get what y is. So what I was saying to you before, we can pick either equation 1 or equation 2. And you can pick the rearranged version of equation 1 either, which is what I'm going to do. So I'm going to pick this equation here. So 3x plus y is equal to 4. Now, we are just after figuring out that x is 1. So anywhere I see x, I'm going to put 1 in instead. So 3 by 1 plus y is equal to 4. So 3 by 1 is 3, so 3 plus y is equal to 4. So you want to get y on this side and you want to bring the 3 over beside the other number, which is 4. So we assume that that's positive because we don't see a sign, so we're bringing it over beside the 4. So it's going to be y is equal to 4, take away 3, so y is equal to 1. So there are your two solutions for that question. Okay, so we're going to do a third example now of simultaneous equations. And this time, again, the question is to solve the following simultaneous equations. And this time, the two equations that were given is 3x plus 2y is equal to minus 6. And the second one is x minus 4y is equal to minus 2. So I'm going to number them. So equation 1 and equation 2. So we need to decide which we're going to get rid of, the x's or the y's. And again, you'll see a plus and a minus, so we're going to get rid of the y's. So we need to make this the same number. So we have minus 4y here, so we'd need to make that a plus 4y. How would we make 2y a 4y? We'd multiply it by 2. So if we're multiplying this by 2, we multiply the whole line by 2. Okay, so I'm going to put that in brackets, multiply by 2. So I'm going to rewrite equation 1. So I'm multiplying all of equation 1 by 2. So 3x by 2 gives me 6x. 2y by 2 gives me 4y, which is what we wanted. And then minus 6 by 2 is minus 12. And we're just going to write equation 2 out underneath. So x minus 4y is equal to minus 2. Now again, you'll see what we wanted there. We have plus 4y minus 4y, so we can cancel them out. And we're going to add the x's together. So 6x plus 1x gives you 7x is equal to minus 12 minus 2. So minus 12 minus 2 gives you minus 14. So x is equal to minus 14 divided by 7. So x is equal to minus 2. So that's one solution. So don't forget, we need to go back now and get what y is. So you can pick any of the equations. So I'm just going to go for equation 1 here. I'm going to write it out. So 3x plus 2y is equal to minus 6. So anywhere I see x, I'm going to plug in minus 2. So 3 by minus 2 plus 2y is equal to minus 6. 3 by minus 2 is minus 6, plus 2y is equal to minus 6. Now here, we want to get y's on one side, so we're going to bring the minus 6 over beside the minus 6. So it's going to be 2y is equal to minus 6 plus 6. So 2y is equal to 0, so therefore y is equal to 0 over 2. So nothing divided by 2 is nothing, so y is equal to 0. And that's it for example 3. So there are the 3 examples for simultaneous equations. I'm going to push some examples or some useful links to some other videos done on simultaneous equations along with some exam questions, and I'd recommend that you attempt them as well. So we're moving on to the second section now, which is linear inequalities. Okay, so we're moving on to the second section of today's lesson, so linear inequalities. So I'm going to give some examples of the use of inequality signs, and then I'm going to go through what each of them mean. So I'm going to put them up here. So examples of inequality signs. And you might recognize some of them. So the first one I'm going to write down is this one. And then I'm going to give another one, and I'm going to go through each of them then. Okay, so let's look at this. So you read that as 2 is less than 4, because the narrow side is facing the 2. So we read that as 2 is less than 4, or you could read it the other way, 4 is greater than 2. But we always read from left to right, so 2 is less than 4. So I'm just going to write that in. So 2 is less than 4. Okay, let's look at the next example. 5 is greater than 2 because the wider side is facing the 5. So 5 is greater than 2. So let's write that down. So 5 is greater than 2. Now the next one. X is greater than or equal to. See that little line underneath means greater than or equal to 3. Okay, so let's write that down. So x is greater than or equal to 3. So you always make sure to look at it properly. If there's an equal sign underneath, that means it's greater than or equals to. Now, this one here, x is less than or equal to minus 2, because the narrow side is facing the x. So let's write that down. So x is less than or equal to minus 2. Another thing I want to add in here is that inequalities often refer to the following sets of numbers. Okay, so, and I'm going to go through that now. So inequalities often refer to the following sets of numbers. Now you're going to need this right up to when you do your leaving certs. This is really, really important. So I'm going to write up 3 sets here. So we have n, we have z, and we have r. And it's really, really important that you know what each of these mean. So n is a natural number. So n is natural numbers. Now, these are positive whole numbers greater than 0. Now, when you're using natural numbers on a number line, you use dots, and that will make more sense when we start looking at number lines soon. So you use dots on a number line. Next one we're looking at is z. Z means integers. So integers, they are negative and positive whole numbers. So you've negative and positive whole numbers. And on the number line, you also use dots. Now for both of these, I'm just going to give some examples. So if I was to write in a set of natural numbers, I'd put in 1, 2, 3, 4, and so on. It continues. Now, if I was talking about integers, they're negative and positive whole numbers. So I'm just going to give an example. -3, -2, -1, 0, 1, 2, 3, and so on. The last one we're looking at is OR, which is real numbers. Now, real numbers is basically everything else. So you're talking fractions, decimals, all that kind of stuff. So everything else. And with that, you're going to use a thick line. And again, that will make more sense once we look at number lines. Now, an example of that would be -1.5, -1, -0.5, 0, 0.5, and etc. So let's just recap over that again. So n is natural numbers. They're positive whole numbers greater than 0. You use dots in a number line. Z is integers. They're negative and positive whole numbers. You use dots. And finally, OR are real numbers, so it's everything else. You're talking about decimals, fractions, percentages, all that. So you're going to use a thick line for that, and I've given examples of the 3 sets there. So we're going to move on to actually putting these onto number lines now, and we'll see what they look like. Okay, so example 1 for linear inequalities. And this is the way you'll see it written down on an exam paper as well. So the question is to solve the following inequality. So solve the following inequality. So this is what it's going to look like. Now, that looks a lot worse than it actually is. So the first thing we're going to look at, always with these, is look at the letter. So n. Okay, so when we see n, we know it's natural number. It's going to be a positive whole number greater than 0, and we know we're going to use dots. So when we're drawing our number line, we automatically know, right, we're going to be using dots. Now let's read what this has said here. So x is less than 5. So we need to show that on a number line now. So I'm going to put 0 just here. I'm going to go up as far as I can go here. So I'm going up in ones. And what's really important here is to make sure and put arrows either side on the number line. So we know that we're going to have to use dots here. So it says x is less than 5. So 5 is here. Are we going to include 5? No, we're not, because it says x is less than 5. Okay? So it's everything after this. Now remember, it's a natural number. So it's every natural number that's going to be less than 5. So we'll include 4, 3, 2, 1, and we don't include 0 for natural numbers. We're going to colour in using dots 4, 3, 2, and 1. Like so. Because we know that we're going to be using dots when it's a natural number. And that's it. Simple as that. So what I do is write a couple of things down as well when you get a question like this. So x is an element of n, so we know we're going to be using dots. And what's it said there? So it's x is less than 5. So it's natural numbers less than 5. So that helps sometimes, is to write out just exactly what you're being asked. So we'll go on to example 2 now. And example 2 is something similar. And it's phrased the exact same way, so solve the following inequality. Okay, so this time is x is less than 3, x is an element of OR. So let's write out what we need to know. So x is an element of OR, that means we're going to be using a line. So use a thick line. And OR means real number. Okay, so real number. So that means you're including everything. Okay, so for this one, we'll draw a straight line. We're going to draw a straight line for our number line. and its x is less than 3. So I'm going to put 3 here and I'm going to go back. So back is 2, 1, 0, minus 1, minus 2, minus 3, minus 4. Now it doesn't matter how far back or how far up you go, as long as you're representing the inequality correctly, it'll be fine. Now this is a little bit different. So x is less than 3. So 3 is here, so we're not going to include 3 because it says x is less than 3. Now because it's a real number and we're going to be using a line, what I'm going to do here is I'm going to circle 3, but I'm not going to colour it in. Okay? Now x is less than 3 means everything that's less than 3 on the number line, all the way back here, and we're going to be using a thick line. So to illustrate that, we're going to colour the line all the way back. So we're colouring it all the way back as far as the arrow. So obviously you'd use a ruler for this. So that's it. That's it represented. I'm going to do an example of an integer now, for example 3. Okay, so for example 3. And again, it's going to be phrased the same way. So solve the following inequality. Okay, so this time it's going to be x is greater than or equal to 2, x is an element of z. Okay, so for this one, let's word out what we're told. So x is an element of z, so we're going to be using dots, and it's an integer, which means we have positive, so it's positive and negative whole numbers. And the other thing then is that it's read as x is greater than or equal to 2. Okay, so x is greater than or equal to 2. So let's draw our number line. So we'll just draw a straight line and then we're going to scale it. We'll just draw a straight line. Now it says x is greater than or equal to 2. So I would put 0 here and I'd go up then. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Now again, it doesn't matter how far up or how far down you go, as long as you're representing the inequality correctly. So we know we're going to be using dots because it's an integer. Now x is greater than or equal to 2. That means we're going to be including 2. So I'm going to colour in 2, and I'm going to colour in all the dots that are greater than 2, all the way up to the arrow. That's it. So they're relatively straightforward. It's just breaking down exactly what you're being asked. So you can see now why knowing the 3 different sets, so integers, natural numbers and real numbers, are so important. Okay, so we're going to do an exam question now based on simultaneous equations first of all, and then we're going to do an inequality. So the question there is to solve the following simultaneous equations. So I'm going to number them 1 and number it 2. So I'm going to rewrite it first of all. So we have 2x minus 3y is equal to 18. And then the second one is 5x plus 9y is equal to minus 10. Now, remember, we are using the elimination method, so we want to get rid of one of the letters. And remember I said before, you have a plus and you have a minus here, so they'll be easier to get rid of. Now, we have a 3y, so we have a plus 3y, and we have a minus 3y, sorry. So I'll just get rid of that. So this is your rough work, so it's minus 3y, and you have a plus 9y. And you want to get 0. So in order to do that, we need to make that a minus 9y, because if you made that a minus 9y, if you added 9y, you'd get 0. So how do we make that a minus 9y? Well, we'd multiply it by 3. Now remember, you need to multiply the whole line by 3, not just the minus 3y. So we're multiplying all of this line by 3. So I'm going to put that in brackets. So now I'm going to rewrite equation 1 and I'm going to multiply the whole lot by 3. So 2x by 3 is 6x minus, so 3y by 3 is minus 9y is equal to, that's going to give you 54. I'm going to write out equation 2 underneath. We haven't done anything to that, so it's 5x plus 9y is equal to minus 10. Now, minus 9y plus 9y, so you can get rid of them. We're going to add the x's together, so 6x plus 5x is 11x is equal to, so 54 minus 10 is 44. So x is going to be 44 divided by 11, so x is equal to 4. So that's one of your solutions. Don't forget we need to go back and get y. So I'm going to pick equation 1. So 2x minus 3y is equal to 18. So anywhere I see x now, I'm going to put in 4 because that's what we just got for 4. So 2 by 4 minus 3y is equal to 18. So 2 by 4 is 8. 8 minus 3y is equal to 18. So we want to bring 8 over here beside the 18. So we assume there's a positive sign there. So we're going to bring the 8 over here. So when it crosses the equal sign, it becomes a negative. So we get minus 3y is equal to 18 minus 8. So minus 3y is equal to 10. Now here, we want to get y on its own. So it's going to be 10 over 3, or minus 10 over 3. And that is a fraction, and that is the answer, believe it or not. Don't let that throw you if you see a fraction like that. That doesn't mean that it's wrong. You just have it in its simplest form. So we're going to do a question now from a paper on an inequality as well. Okay, so the last question this evening, we're going to look at an inequality question from an exam paper. So, graph each of the following inequalities on the number line given. Note, x is an element of a different set n, z or r in each case. So we know n is natural numbers, z are integers and r are real numbers in each case. So for this first one, A, x is greater than or equal to minus 2. X is an element of z. So let's write out what we need. So if it's z, we're going to be using dots. We know because it's z, it's going to be either a positive or negative whole number. So when we're putting it on the number line, x is greater than or equal to 2. So x is greater than or equal to, minus 2. So we're going to be including minus 2 here because it's an integer. We're going to colour in all the dots to the right of minus 2 because it's greater than minus 2. And we're also going to colour in the arrow here because we intend the numbers to continue on. So if we look at the second one, you will see that x is greater than or equal to minus 2, where x is an element of n. So this time, it's a natural number. So again, we use dots, but they are positive whole numbers only. Okay, so we have positive whole numbers. Now because of that, we are not going to colour in minus 2, we're not going to colour in minus 1, we're not going to colour in 0, but we are going to colour in all of the natural numbers after 0. So 1, 2, 3 and 4. And again, we're going to colour in the arrow to intend, or to show that we intend the number to continue. So we couldn't include the minus 2, minus 1 and 0 there because they are not natural numbers. And then finally, x is greater than or equal to minus 2, where x is an element of r, so real numbers this time, which means we're going to be using a thick line. And also, we're including everything. So for this one, we're going to colour in minus 2, and we're going to colour in a thick line all the way up to the arrow because we're including everything here to the right of minus 2. So anything that's greater than minus 2. And again, we colour in the arrow because we intend the numbers to continue. I'm going to paste in some links into the chat, which will include some useful videos and also extra exam questions that you can attempt. And I will see you next week.